This video is for January 3rd, January 4th, and possibly spilling into January 8th for UB Day, folks. And we're looking at factoring, how to factor different expressions, how we can tell how to factor with different expressions. And then we'll look into next class looking at how we can solve using factoring. But we really focused on 4 different types of factoring, really 3, but I subdivided it into 4 different sections. And so let's look at this type of factoring here. Here, if we look at this expression, we really have 2 terms. Terms are what are being separated by addition or subtraction. So here's one of our terms, and here's the second one. Anytime we're factoring, really we should start by looking at, do the terms have any factors in common? And what we mean by that here is, if we look at the coefficients, 6 and 9, are there any numbers that go into both 6 and 9? And here, yes, there are numbers that go into 6 and 9. That number is 3. So because 3 goes into 6 and 9, then what we can do is factor out a 3. Then we look at the variables. Here we have x squared, x to the 5th, y cubed, and y. Well, as one student put it, they both have at least 2 x's in common. Here I have 2, here I have 5. So I can take away 2 from here and take all those x's out. I can take away 2 from here, leaving 3 left. So we can factor out an x squared. Similarly, we can factor out, here we have 3 y's. 1, they at least have 1 y in common. So then we can also factor out a y as well. Now, if we factor out 3x squared y, then we just can't do that nilly-willy. We have to make sure that we divide both of these terms by what we factored out. So 6 divided by 3, that's going to give us 2. We had x squared, but we took out x squared, so we don't have any x's left in this term. Here we had y cubed, and we factor out a y, so it'd be left with y squared minus 9, but we factored out a 3, so that'd be 3. We had 5. We factored out 2. And we had a y, but we factored that y out. So this is what our expression would become in factored form. And we can always check our work if we wanted to by distributing. So if we multiplied this quantity here by these 2 things, we would end up back to our original. Let's take a look at this one here. Here you have 3 terms. So we have to figure out what is common in each of the 3 terms. If we look at the coefficients 4, 8, and 10, do they have any numbers any factors that they share in common? Well, of course, they share 2, so we can factor out a 2. We have z to the 5th, z cubed, and z. They each at least have 1 z, so that is what we can factor out there. If we factor out 2z from this, we get 2z to the 4th. Since I had 5, I took away 1, plus 4z squared minus 5. And that would be your factored form here for that expression. So the idea is, if anytime we have an expression, we want to factor it, the hope is that we can look at each term and think, is there anything in common? Maybe start there. If not, though, then we have to look towards a different type of factoring. I would recommend pausing, going through these 3 problems. I will start the next video, showing the solutions to these 3, as well as the solutions to some of these problems down here as well. So I would recommend pausing, trying to factor these 3, and then checking your answer on the next video. But let's go on to the next type of factoring. So here, like we said, 6 and 9 have a 3 in common, so we can factor that out. If we look at these 3 terms, the x squared, the 7x, and the 12, they don't all have an x. They don't all have numbers that go into each other. I mean, 1, but anything divided by 1 is itself, so we can not worry about that. So you have to resort to a different type of factoring. And these types of functions, equations, whatever you want to call it for this, we have a square term here, and then we have just that quantity, like a number and the quantity, and then a constant term. if anytime something takes this form, these are what we call quadratics. And the number in front of our x squared term, or our a value, would be 1, since there's no coefficient there. If that's the case, then what we're going to try to do here is find two numbers or a product. Two numbers that multiply to give us 12, and those same two numbers should sum or add to give us our middle term, -7. So we need to be thinking two numbers that multiply to give us 12, that add to give us -7. Those two numbers being -3 and -4. -3 times -4 gives us +12. -3 plus -4 gives us -7. And so since they're both negative, then this would factor as x minus 3 times x minus 4. And so that would be our factorization here. And we could check it. If we wanted to FOIL x times x, it would give us x squared. X times -4 would give us -4x. -3 times x is -3x. Ooh. And -3 times -4 gives you +12. And these would combine to give us -7x. So it gives us back to our original expression, which shows that this is a correct factorization of this quadratic. Let's see if we can do something similar here. Quadratic still, we have a square term, that quantity there, and then just a constant term. If we want to do that, let's say a product, we need two numbers that multiply to give us 8, or a product of 8, and that sum to 6. 4 and 2 should work here. And since 4 and 2 are both positive, it would be z plus 4 times z plus 2. So this is a way that we can factor quadratics, if they factor. Not all quadratics are factorable, but if they factor, our number in front of the square term is 1, or in other words, it doesn't really have doesn't look like it has a leading coefficient, then we can factor it in this way. That is an important piece, though, because the second that we have something that looks like this, then we're in trouble. And because of the 2 here, we have to do something about that before we can factor. But we'll see that on the next video. Again, I would recommend pausing, trying to factor these two expressions on your own. I will post the solutions to those two, as well as these three, on first thing on this next video, and then we'll also look at the backside of the two other types of factoring expressions.